Hi class. Today we're going to be looking at graphing the cosine function and then how to graph the cosine function with some transformations. We're not going to change the period of our cosine function. It's going to remain 2 pi for this example, but we are going to look at other transformations. So the first thing we want to look at is just our parent function for y equals the cosine of x. If we look at our unit circle here, I've marked our axes with the coordinate points assuming our radius is 1. And the cosine function always corresponds to our x value of the coordinates as we go around the unit circle. So if I look at the angle 0, then the cosine is going to be the x coordinate. So from 0, it would be 1. And then at pi over 2 on our unit circle, the cosine is going to be 0. At pi on our unit circle, cosine is going to be -1. And at 3 pi over 2, our cosine is going to be 0. And then if we come all the way back up to 2 pi, we'll get right back up to 1, which is where we started. If we look at this curve, we can continue the curve if we go into our negative angles, which just means going around our unit circle clockwise, the other direction. So I can continue my pattern as we saw with our positive angles and finish a nice graph with my cosine function. Now, if I want to graph some transformations, and I have a kind of a complicated example here because I want to show you a bunch of stuff, we want to take it piece by piece. I always suggest starting with the vertical shift. So this piece right here is going to shift our unit up 1 unit. And the way that I graph it is I actually take my pencil and I make a dashed invisible horizontal line to show that my x-axis has been shifted up. So my whole graph, including the center of my function, has been shifted up 1 unit. I also have a couple things happening here. I have a reflection, and it's in the vertical direction, so it's going to flip it upside down. And I have a amplitude change of 2. So it's going to vertically stretch my function. So instead of going up to 1 and down to -1, it's going to go up to 2 and down to -2 if I don't pay attention to my vertical shift there. And then the last piece I have here is what we call our phase shift. And the phase shift here is pi units to the right. So that's just going to be a shift in our horizontal direction. So to put all this together, we've already drawn our red horizontal dashed line there representing our shift 1 unit up. Our cosine function would start typically up at the point 0, 1. But we're going to do some things to that. We're going to shift it pi units to the right. And I'm going to be kind of along this red line now because I have shifted everything up. So if I shift everything pi units to the right, and then instead of being up 1 above my center, I want to stretch that to be 2 above my center. But then I reflect it. So there's a lot of stuff going on here. If I reflect that point now, instead of being up to, I'm going to go down to from that central line there. And now I can kind of, once I get that starting point, so this is where that 0, 1 shifted. It shifted kind of to tie it all together. It shifted. So here's 0, 1. It shifted 1 up, pi to the right, Then it stretched to 2 with my amplitude, and then it flipped all the way over upside down to this value here. So now I can follow my pattern. I haven't changed my period at all because there's no b value, no number being directly multiplied to x. So from here on out, I can go up to my center every pi over 2 units and kind of just follow this through. So since I went below 2 on my graph from the center line, I'm going to go up 2, and every pi over 2 units, I either go up or down or right back to the middle. And then I can draw my curve. And there it is. So kind of a lot of things going on there, but hopefully you were able to follow. Yeah, and I think that'll do it. Have a nice day.